Hello everyone, and welcome back to the 10th and final lecture of our introductory course to quantum computing. Today, we'll be talking about the quantum future, including where quantum computing is going, some of the companies that are currently researching quantum computing, and how to get into quantum computing through education as well. So, let's start this lecture off by talking about some of the companies that are in quantum computing. I like to separate the companies in quantum computing into two main categories, including tech giants and also new quantum startups. So, a lot of the tech giants in places like Silicon Valley are conducting a lot of research into quantum computing. These companies include Microsoft, Google, and IBM. A lot of these companies also are conducting research into both hardware and software, which is something that I find is slightly different with new quantum startups, and I'll talk about that on the next slide. However, there are definitely more tech giants than the three I've listed here that are currently investing heavily into quantum computing, and I think that the investment of these tech giants into quantum computing shows the potential that quantum computing has and how they're investing into it. So second, we have the new quantum startups. These include companies like T-Wave, who are doing research in quantum annealers, Rigetti, who are doing research into quantum hardware, and I think in specific superconducting qubits. And finally, IQM, who is a European startup who recently received a lot of funding and is also conducting research into quantum hardware. So I think you can see a similarity here, but a lot of these new quantum startups, I feel, invest heavily in quantum hardware as opposed to the software. There are definitely some startups investing in software, but I feel like a lot more startups are investing in hardware compared to software. So, in order for a lot of these quantum startups to continue their research into quantum computing, they obtain outside investment, and that's something that I want to take a look at on this slide. So, we can see on the left-hand image that the amount of investment going into quantum computing is increasing by the year. Sometimes, some years it'll decrease slightly, but I think overall the trend is that the investment in quantum computing is increasing. Additionally, on the right, we can see some of the hubs of quantum computing throughout the globe. So this map shows where investments are going to these companies, and we can see that there are large hubs in places like the United States and Canada, Europe, and also China and Australia. So quantum computing investment is something that's going on throughout the world, and I think this was back in 2018. So a lot more investment has come in since then, and we can see these hubs continue to develop around the globe. And of course, all of this investment into quantum computing is not without its own progress. We've been steadily increasing the amount of qubits in our quantum computers. So we can see from this graph that we started out at 2 qubits in 1998, then moved on to 5 and 7 qubits in 2000, 12 qubits in 2006, 28 qubits in 2008, 50 qubits in 2016, 72 qubits in 2018, and although the 128 qubits by Rigetti I don't think was actually reached, earlier this year IBM released their 128 qubit quantum computer called the Eagle processor, and I encourage you to read more about that as well. We can see here that the amount of qubits in quantum computers is increasing quite exponentially, and we want this trend to continue so that we can more quickly develop the best universal quantum computers, as universal quantum computers are estimated to require thousands or even hundreds of thousands of qubits in order to run the best. Now, here is sort of where quantum computing is headed in the future in terms of hardware. So this is an image of IBM's quantum roadmap that they released, I think, last year. So we can see that last year they planned to have the 127 or 128 qubit Eagle processor out, and that came out early this year in January. So they're slightly delayed, but still making good progress with quantum hardware. In 2022, IBM plans to have a 433 qubit Osprey processor, and in 2023, they plan to have a 1121 Condor processor. After this, it's unknown, but we can see how companies are ambitious in wanting to improve quantum hardware. One last thing I want to talk about regarding the investment into quantum computing is the United States Quantum Initiative. So in 2018, President Trump created the National Quantum Initiative Act, which marked, I think, around $1 billion in spending to research centers around the nation to conduct research into quantum computing. So many research centers received a chunk of this $1.2 billion. So for example, Fermilab, we can see gained or received $115 million from the National Quantum Information Initiative Act. But we can see that the U.S. is not lagging behind in government spending in investing in the quantum industry, which I think is very good to see. So I want to sort of wrap up this course by talking about how you can dive further into quantum computing. Quantum computing is extremely interdisciplinary, and we can see from this infographic that any education in or experience in computer science, chemistry and quantum mechanics and physics, creating algorithms and mathematics, and even your business side of skills like your communications and things like that can allow you to dive further into quantum computing and some of these quantum computing companies. Something else that isn't on this infographic that I sort of want to mention is the electrical engineering side, as it is a really major part in quantum computing that isn't on this infographic. However, basically all of your STEM subjects are involved in quantum computing somehow, so as long as you're involved in a STEM topic, it'll be probably quite easy to further your journey in quantum computing. As for whether if you're not in STEM, there are things like the business side of things where you can dive further into quantum computing as well. And finally, I want to end this course by showing you guys some other resources that you can use to learn more about quantum computing. So Coursera, FutureLearn, and Udemy are all online services where other people can upload their courses. So it is a good resource to find a lot of different quantum computing courses for beginners, intermediates, and at the advanced level. In the middle, we have Qubit by Qubit, who are offering introductory quantum computing courses to high schoolers and I think middle schoolers now as well. I took their introductory course on quantum computing from 2020 to 2021, so I would definitely recommend it to other people as it gives you a very good foundation of what quantum computing is and goes further into some of the concepts that we talked about during our lectures. Finally, we have MIT X Pro, which is sort of a marketplace where you can search for courses and pay money to take them. They have a really good quantum computing course, which I would recommend, although I haven't taken it, but I've heard good things about it. So I would recommend that as the final resource for learning more about quantum computing. So that's it for the whole course. This was the last lecture, and there's no more lectures after this. So I hope you guys enjoyed all the lectures and learned more about quantum computing from them. If you would like to learn more about quantum computing, take a look at the resources that I mentioned on the previous slide. And yeah, I hope that you guys learn more about quantum computing in the future and continue your journey into quantum computing. Thank you.